know how to do. For example, I'm pretty sure that each and every single one of you at some point in your life has used either a ruler and or a tape measure.
Yes.
Okay, you knew how to find how long a piece of wood is, how far it is from here to there. You know how to do all of that. That's easy. So you know how to measure from point A to point B. You know how to do that. Now, let's throw some things at it just to kind of change things up. Instead of starting at 0 and going to 6, knowing that that much is 6, what happens if you start at 11 and you have to go to 23? How long is that segment? 12. Okay. What's happening here is that you're trying to measure.
What's the thing called for
The menorah?
Is that the camp thing?
Yes.
Then yeah, it's called menorah.
What?
The thing on
The thing in the drill test, that was the whatever. No, I'm not. I'm the full.
No, that.
I know.
Anyway, so let's go back to this. When you measure distances, when you're measuring lengths, are lengths ever negative?
No.
No. Can you, when you walk backwards, you're not walking a negative distance, you're just walking a different direction. What is the terminology in math that keeps everything positive? What is it? Absolute value. Remember the absolute value, those little upright bars?
Yeah.
Absolute value stands for the distance something is from 0. It's how far you know things work. It's always making sure that your distances are positive. So in essence, what you should have done besides 10.5, what I would have done is taken the 23, subtract the 11, and make sure that that distance is positive. It was, so we didn't have to worry about it, but that's what we were doing. You take that and you wound up equaling 12. So, or you could have just sat there and counted. If you have sandals on, counting would have been even easier. 12, 11, 13. 12, 13. I can count. That's not that anyway. This is why I don't count papers when I pass them out. Just chunks of them. Does anything change if this is a negative and this is a negative?
No.
No. Nothing changes. Now, one of the things that will happen though, remember your distance is always going to be positive. All you're doing is taking -2, subtract the -11. And if you know how to put that in your calculator, you're never going to get that wrong. On all of your calculators, there is a negative button. It's not the minus button, it's the negative button. There's a big difference. There's a big difference between those.
Whoa.
You should never get silly math questions wrong. There's no reason. Okay? Now, one of the things that you can get wrong is if you write down the wrong information. And I'll show you something what I mean by about that here in a second. So this is what we're talking about. Segments. Adding them, subtracting them, figuring out how far apart things are. It's called, oops, got ahead of myself. It's called segment addition. Segment addition is nothing more than whenever you have collinear points, you can add the distance between them to figure out how far the whole thing is. In this simple example, how many segments are there? 3 of them. There's 2 smaller ones and a larger one. So what happens is the sum, what does sum mean? Add. The sum of the 2 small ones always equals the large one. That's all it is. And you knew that. If I walked from here to here and it was 2 feet, and from here to here is 3 feet, how far did I go? Wow, real tough. All right. What's different here is that you're using some very, very simple terminology for something weird in geometry. Okay. So what we do is we write it out. Smaller segment plus smaller segment is larger segment. Does it have to be just 2 points? Or sorry, 3 points that are collinear? Could it be 7 points that are collinear? Yeah, it doesn't matter. It does not matter at all. It doesn't matter. As long as they're collinear, this always works. Okay. Excuse me. So as long as we're collinear, everything's good. Now, this is when we start to mess around with you a little bit. Let's say this is 8, and the whole thing is 32. What do you do to figure out the missing chunk? Yeah. Right? Yes. It is quite literally that straightforward. There's not much weirdness to it. It's just you're dealing with a geometry picture as opposed to, bless you, 8 plus something equals 32. The relationship between the algebra and the geometry is, if you want to just grab it and go, or you just wrote it out, you're holding your okay. Figure it out. Do that. All you're doing is you're incorporating the algebra that you've all learned with a geometry term.
Yeah. That's my guess.
Real fast. Okay. Now, the stuff that we're doing as far as math is concerned, you don't need to have a super fancy calculator to do any of this right now. Every calculator is going to work. It doesn't matter what you have. The most complicated thing we're looking at is probably a 2-step equation, and it's not going to be that tough. Okay?
Yeah.
Now, there is a suggestion that I do tell you guys to do. When we have problems like these, I know that when we're dealing with just numerical ones, they're really, really easy. But when we start to get more complicated with a little bit more of the algebra, which we will here in a little bit, I'm going to make a suggestion that you write down everything that you're going to do before you do it. What I mean by that is, knowing that you've got collinear points, knowing that you have 3 of them, so you've got 2 smaller that make up a whole, write down what chunks add together to get the bigger one. Because then when you start to have problems that don't have diagrams, just statements, you'll be able to figure out how things flow. Okay? Geometry, like I've said before, is hugely visual. And the more information that you can put down on paper before you do it, the easier it becomes. Okay? Oh, you've got the cool black one? That one's sweet. You know what that one does? That one does integrals. That's what that menorah thing you thought was in the back there. See that where it's shaded underneath the curve? Well, it's a bad picture, but that button that looks like an S with the 2 dots above it and below it, it's called an integral. It's a calculus thing. It's a $20 calculator that does calculus. You're like, I don't know. It's pretty sweet. Those are cool. I like it because does it have the shiny silver buttons? I just looks cool. Shiny. It's like swirl. All right, write down what you know. This is what I mean by taking an extra step just to write down the parts. It forces you to, well, 2 things. Slow down and then substitute correctly. So many times mistakes are made, especially in these classes, that you just go too fast. Okay. It really is. People go too fast on things and you just make that dumb mistake. Fill in the blanks. 21 plus something, 36. What's the something? 15. Okay, it's 15. So GH, it's 15. Okay? It's nothing more than just piecemealing something together. We're not trying to make anything too crazy, anything too difficult on it. But wait! It gets even better. I know you're super excited.
No,
I know.
it's not.
It's algebra mixed into geometry. We'll go right to the geometry. We'll go right to the algebra then.
Come on, man. It's too complicated.
It's really not. So in this case here, we're going back to the idea of two segments equal the larger. Well, instead of it just being numerical values, we're just going to go right ahead and say that we've got algebraic statements to it, which means we got to solve for x.
All right.
Now, the difference between just solving for x in algebra versus solving for x in geometry is that in geometry, a lot of times you're solving for x, and then they're going to ask you to do something with it. Whereas in algebra, you solve for x, say, oh, x is 6, and went on your merry way. In geometry, if x is 6, you would substitute in to x to figure out the different segment values, or angle values, or something. Each question would tell you differently. Sometimes it'll say, solve for x. Sometimes it'll say, solve for EF, solve for FG. It will be specific to each problem. This one I kind of slid over to blow it up a little bit. It did ask us to find both of the two smaller segments, the EF and the FG. So, are these points collinear? Yeah. Which means two smaller segments equal the big one. Well, what's the segment EF? 8x minus 14. Look at that. Oh, who would have thunk it? And FG is? EG is? 59. And you're back to what winds up being a two-step algebra problem. But you have to do something before you can solve. What do you have to do? Combine like terms. Very good. 8x and 4x is 12x. Good. You must be wearing sandals. All right, this one's going to be tough. Negative 14 plus 1. And like I said, usually the most complicated things that we're looking at to start, or really in most cases, it's a two-step algebra problem. It's really nothing interesting. What do you do next?
Plus 13 to the other side.
You add 13 to the other side. So what do you get?
12x equals something.
Let's slide this up.
Now you divide.
There you get?
6, 7.
You have a calculator, right?
No.
Use some sort of machine that would allow you to compute values. Now, again, it said x is 6, but if x is 6, I have to take that value and substitute it into here, in here.
Come on, bro.
I know, I'm sorry, I am asking a lot, but I have a feeling that you'll be able to figure it out.
All right,
All right.
Mr. Sir.
4 times 6 plus 1. 25, okay. So FG is 25. All right, 8 times 6. Subtract 14.
Damn, bro, you straight?
59.
Come on.
Hey, don't hurt your
Does
hand.
34 and 25 add to 59?
Yeah.
Yeah, so that means we probably did okay.
Hold on. Let me just casually just observe this.
Casually observe.
The answer.
Did we do all right?
Yeah, it was kind of easy after a while.
After the
And that's what I want. I want it to be easy. All right, I want it to be easy. All right.
Wait, hold on. Hold
What do you hold on? There's 2 problems. Take a couple minutes, solve them.
Hey,
There are 2 problems. Take a couple minutes and try them. You got it. Write it out. Hey, whoa. Shh. Write it out. Draw the picture. Write down what parts have to add up to equal larger parts. Fill in the blanks. 2 steps. Quick and painless.
I don't think this was 2 steps.
That was.
It wasn't.
So, with any luck here, we know that TW, so I have to write this, TV plus VW. So 3x, x plus 8. Sad puppy back there or something? He's actually hear somebody whimpering. So 3x and 1x is 4x. Ladies and gentlemen, subtract the 8, you get,
24.
what's x then?
6.
Take that value of 6.
It's 14.
14.
6 and 8 is?
14.
There you go. Same exact deal on the other side. On the other side, we set it up the same way. 2x plus 3, 3x minus 1 is 27. Combine your like terms, you get 5x plus 2, I believe.
Yes.
From here, you subtract the 2.
Yes. On both sides.
That one's real easy. I think it asked you to solve for yz, correct?
Yes.
3 times 5 is?
15.
15 minus 1 is?
14.
Oh, that's just dumb luck. Is your answer always 14?
Yeah.
No. One thing to show you real quick, and this happened last hour. If we go back to this problem here, and I just want to, don't write this down, but I want to show you something that happens pretty regularly in geometry. So here's the problem. We're setting it up. We write down 3x plus x plus 8. You combine your like terms. But here, what happens if you do that from reading all this through? You subtract it out. What is that then? 14, I believe. Yeah. Is that right? Yeah. Divide that by 4. You get x is what? 3.5. Okay. Let me ask you this. Did you, without looking at this, is segment addition set up correctly?
Yes.
Is combined like terms set up correctly?
Yes.
Is the math done correctly?
Yes.
Is that problem right? Yes.
Oh. Whoa. That's not the answer.
And here's the thing. I would never mark this wrong if you did that on a test. You know why? You showed me you know what to do, you just don't know how to read. Okay? You know how to do, you know how to math.
You just can't even.
And I'm smart. Yeah, she's not smart. But here's the thing. This happens all the time. And what happens a lot is that if you don't show the work, I won't know that you know how to math. So if you just wrote down x equals 3.5 because you just press a bunch of buttons on your calculator, then yes, it's wrong. But if you show me what you did, you know how to combine like terms, you just wrote 22 instead of 32. I don't mark that wrong because it's not. Okay? It's not. You know how to do it. You just made a stupid mistake by writing the wrong number down. So please, anytime you're doing algebra, anytime you're copying things down, double check it, but please just show the work. It doesn't take long to figure out what you screwed up. If I see 3.5, I'm like, oh wait, something's not right. Oh, they did this instead. It happens all the time. Please, please, please show your work. It is hugely important. It becomes even more so important later on when we get bigger pictures. Okay? The math isn't difficult. It's just sometimes getting your brain to look at it and write things down correctly. I mean, how many times have you guys been looking at a math textbook before? You read part of one problem, then you write it down, you look back up, you read part of the second problem by mistake. It happens all the time. I can't fault you for that. I can't. It's just a dumb mistake, but you knew how to do it. Okay? So remember, show your work, and as long as I see that you're setting everything up correctly, that's all I can ask for. If you get the right answer, great. But it's more important that you know how to get to it. All right? Does that make sense? Tomorrow what we'll do is we'll talk more about what are called midpoints. We won't get to that. I'm not going to bother this one today. And so let's just do this. We skip ahead here. Just put up the homework for now. Don't do all of these. We're just going to go 9 through 17 odd for right now. If you give me a second or so, I'll put them up on the board. Otherwise, if you've got your Chromebook, by all means, go ahead and do that screenshot, take a picture, whatever. Tomorrow we will talk about a little bit more of the algebra of this, because I've got a couple others that are a little bit more complicated as far as the actual algebra process. But then we'll talk about midpoints and setting things up that way. Okay? What do you think a midpoint is? Real tough.
Midpoint.
Yes, ma'am.
Can I write it on the back of my homework?
Absolutely. That's fine. Yeah. As long as you know where it is, it's fine.
I don't know if we're like having turn on it or not.
No. If you want to keep tabs on it, that's fine. That's actually a good idea. If you have like
Notebook?
it's a notebook that has the just for homework,
Yeah,
just keep
that's what
adding to it.
Yeah, that's
Just
what
keep adding to it, and then flip back to another page for notes and go back to the homework. Whatever. It works. Okay.
I do it in between.
All right. Let me pop this up here for you.
How many more?